Hey there, guys, and welcome back. I know we said that this evening's stream would be probably video games, but that was assuming that we'd have a good stream this afternoon, and that was a bit of a scuffed stream. So, one of those things, I was not quite content with only having one good creative stream today, so I decided to come back and do another one. So that explains why this one is not me playing video games. So last time we were in here, we went ahead and did the map animation here. And that was more or less good for right then. But since then, if you've been following the sprite stuffs, we made up some more sprites and they function a little bit differently. So it's one of those things I want to get these integrated into the program. And we'll go from there. Now, one thing I just realized was I did not grab the other one that we made today, this morning, the stream GIF. And that one is just a sample for the time being, but it will be useful to have. So I'm going to go ahead and bring it over to samples. Paste. There we go. And yep, it showed up. And I can get rid of this one because that's just a PNG. So we'll move that one to that, and we are back to the sample file here. So this one, I guess we'll go ahead and just build off of this canvas. No reason not to. We'll just move the sprite somewhere else. So first matter of business, if we look at this, we have something of a sequential sprite. Now this one is just fine to have. Like this one we should be able to handle just fine if we look at sprite. Obviously, we have this sprite 2D with movement, but our normal sprite. Oh, that's funny. I thought I had. That is hilarious. Okay, I thought I had one that just had the it's in there. So the point being is that our sprite is not moving. And evidently I forgot that we do not have actually a sprite that only does animations. I think we might have had that at the very beginning. And I might have overridden it and saying, well, sprites that don't move don't do anything. So I guess we'll go back here and let's see. Any of this stuff looks like it won't be useful. No, I don't think so. Okay, we can still use this. So class sequential sprite, I'm going to call it sequential sprite and define in it representation. Actually, we were not. Okay, we were providing a way to load it immediately. So, yep, just want to check that one. That's going to be a list. And that will be empty. So this is a sprite that's just going to cycle through its representations. And I think it's alright to just pass this directly to the sprite base class. So, sprite base class does not actually accept it. I take it back. So self.representation equals list representation. Let me just glance down here really quick, refamiliarize myself because evidently I misremembered this part, and define, or actually self.current index. Location is correct. Self.frame. This. I'm wondering whether or not we should make another class, another base class that has self.frame, and then both of these extend it. I'm gonna leave that separate for now though. And then define move self dot frame plus equals 1. Define let's see, define move self. Yeah, move needs to be implemented. Move get image. Get image, I don't know why I did not make that a base, what you call it, a base feature. That seems like something that should be a base feature. So let us go ahead and move that up here. And again, ooh, bless me. We'll go ahead and just make sure that the subclass implements it, because all sprites are images, so all sprites should get images. Define get image self, and here we will return self dot representation self dot frame. And up here we're gonna go ahead and fix this guy. This guy's gonna loop just like the other guy. So if self dot frame is greater than self length self dot representation -1 self dot frame equals 0, and that will loop us back around. Is that wrong? Length self, so it's self dot frame 0, 1, 2, like this 3. Yeah, that should be wrong. That should be self dot length -1. Unless I'm going crazy. Unless I'm going crazy. It's definitely a possibility. Okay. So now we've got this sequential sprite here, and this is going to be a sprite that just animates itself at its location based on a list of animations that it cycles through. Anything else we want to do here? I don't think so. So I will go ahead and hop over to sample, because now we can animate the, I mean, that should be all we need to animate the 3D printer. So let's go ahead and bring the 3D printer in. This is where we start animating, right here. So let's go ahead and bring in printer equals sprite dot sequential animation, and let us bring in this is loading walk animations. And this is loading printer animations. One of these things, this is not exactly Pythonic, I don't imagine. Arguably you could just do define load walk, and that would be a little bit more readable. And I guess I will do that, just for the cleanness of it. Return directions, define load printer, for Z level in range 1 to 5, 6, 1 to 6. and frames equals, and then utils dot import frame sprite sheet sample dir, and this will be an f string prusa z I or z level rather resolve. All right, and that loads the sprite sheet equals, and then frames dot extend utils dot split sprite sheet sheet row height column width. The sprite size actually should be the same, let me double check that one, as our walking character. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25. I think we're 35 actually. 32. Alright, so I'm gonna hop over to pixels then, and let me check that file really quick. And this is a 32 by 32, so it is 32 by 32. I just have a bunch of white space on top, which is fine because it's supposed to be smaller than me. That makes sense. Let me just do this before I forget about it because I just saw it when I came back in. So that's now load walk. Sprite size and sprite size. And fix that resolve. Frames.extend should be good, and now we can just return frames. Cool. Representation equals load printer function canvas. Actually, let's move this up now, and then canvas add sprite printer, and we'll put this our canvas size is 500 500. We'll put this middle of the canvas, 250, well, middle-ish of the canvas, 250 250. So let us let's see. I guess for right now we'll just animate it. Dot move sprite. Printer right. Direction offset. Offset equals 0 0. Is probably what we're gonna have to do because our whatchamacallit is not actually moving. Now let me take a look at that canvas and see how it handles move sprite. Target location, handle move, execute move, sprite.move direction, sprite.location equals. So we're gonna have to come back here since that's the way we're handling it right now. It doesn't really care because it's actually alright, so let's imagine yeah, so these sequential sprites, I'm thinking that this should only be a class for sprites that do not move around, so I will go ahead and accept this direction or offset as none and just ignore it. I'm trying to think of a sprite that would move and not be a sprite 2D, and I can't think of any. About the closest I got is like some kind of cloud, but even then, you know, if the cloud starts moving backwards with the same shape, that'd kind of be weird, right? So you kind of expect it to change shape when it changes direction. Yeah, I can't think of any examples of a sprite that would be able to move in 4 directions specifically to begin with and not change its shape. And even then, even if it doesn't change its shape, you can still initialize it as a sprite 2D just with all the same animations. So yeah, I don't see a reason for the sequential sprite. I mean, we might even better off calling it a stationary sprite. Yeah, let's call it a stationary sprite just so that we get the point across. So let's come back to sample and change that then. Stationary sprite. And let's run this and see what happens. First I gotta m scripts activate, forgot to do that. And now we can do python sample.py. I think we're in the correct oh, resolve is missing a parentheses. Subclass has not turned. Okay. So that brings us back to the canvas problem of handling all sprites the same way. Let us see. All right. For ease of use, we decided that these are important functions right here in the last stream, evidently, which is why we moved them up to the top level here. There is an argument that we made a mistake there, but for the time being, I'm going to assume that I had really good reasoning for keeping them around, and we will just valid direction self return true. We'll just code around it for the time being. Define determine direction self offset return none. Define determine offset self direction return none. We'll just do that, hack that together for right now, and if I decide that that really is just stupid of me to have that in there, we will come back and fix it. So, as you can see, our printer is in fact printing. Now, the last thing I want to do here with the printer is, well, there's a couple things actually. Before I do it with the printer though, let me go ahead and how do we want to do this? Well, first off, let me turn the fan off really quick. I just realized the fan's still on. Hopefully that turns it off. One of these things, it was at a weird speed that I don't normally keep it, so I had to figure out which speed it was actually off. Must have tried to turn it off earlier and did not click enough times. So, first thing I'm going to do here, as I was going to say, is bring in the desk. So let's define load desk. Frame, well, the desk is only going to have one frame. That's the trick here. Because the next thing we need to work on is getting stuff in place. And this is going to actually be important for the printer because it occurred to me that our blue man on the printer does not have to be there. So we are going to resolve this issue with, well, it's not even an issue, but resolve how we're going to handle the desk. And in doing so, we'll make room for the printer. So let's go ahead and bring that in. Desk equals, desk frame, I guess, equals utils.import sprite sheet sample dir desk1.png. I'm not entirely sure why there's one in there. We'll cry about it later. And then utils.split sprite sheet that, and the desk has a different size. So let me go check the size on the desk really quick. Boom, boom, boom. The desk is 45 by 32. 45 by, actually that is row height. Row height is first, column width is first. Row height is first. Why is row height first? Oh, I guess because we're, okay. I think I understand why, but I'm just going to call that sprite size and then 45. And we can just return this. Desk equals sprite dot stationary sprite representations. And actually, let me return this as a list. Load desk, and we will go ahead and put that. Let's move this guy over. Let's put the desk in the middle now. So this will be like 400, 400, bottom right hand corner. Canvas.add sprite desk, and this guy is going to be center. 250, 250, center-ish again, center-ish. And let's go ahead and run that code just to make sure it happens. Huh. Okay. Let's back up a second, rerun it. Okay, so I just, because I didn't shrink that, I just commented out the add sprite on the desk. Let us see. What is wrong here? Self.frame plus equals 1. If self.frame is greater than 1 minus 1 equals 0, so 1 is greater than 0. Self.frame equals 0. So the desk should be returning to frame 0. It should be having its location set. Let us go ahead and hop over to canvases and add sprite and see how we're setting location. Sprite.location equals location. So location should be, okay, I did use a tuple. That is good. Desk, sprite, load desk. Bum, bum, bum. Oh, let's see what this sprite sheet actually holds. We might have split that wrong. Image, just print it, I guess. We might have split that wrong, which is the reason why. Oh, splitting it automatically makes it a list. Good call. Which is why we had extend, frames.extend. All right, and it works this time. Cool, 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 cool. So let's come up here, look at the GIF. And I do not, oh, we're zoomed in. Zoom out. And zoom out. Where am I at? I am off the screen, huh? Let's close that, open it back up. That's not good. I am not supposed to be able to walk off the screen like that. So, that is clearly an error. It looked like we were able to fix that problem last time, so call back if response is false. So let's go ahead and check the single page. If target location 0, if 0 is greater than So location in theory at one of these points is going to be minus 1, minus 1, 1, let's say, or minus 1, 0, minus 1, 0. So on this first check, minus 1 is greater than target location. Half a second. Am I going crazy? Minus 1 greater than 0. Or 0 greater 0. Oh my goodness. There's the 0. 0 minus 1, 50, 40, whatever. False. Yeah. Okay. Yeah, I mean, this is just a silly mistake on my part, so... There you go, true. Yeah, that was just a silly mistake on my part, so... It is all better now. Let's go ahead and run the script again. Get a new map. Bum, 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 bum. Where is our GIF? Not animated. Okay, it's not animated because we are not animating. Maybe? Actually, the... Huh. 0 target location is... 0 is greater than... So that should be false there. Target location, if the target location is 0, that is greater than. So that should be false. So that should be false, false. 0 is greater, false. Target location is, oh. There we go. Map. There we go. And there we are trying to run off the side, and it's not working this time. Cool. Alright. Much better. The other thing to say about that is obviously you saw how this guy was flipped, and we weren't running off the top. That's basically where I screwed up. The other way of just writing it is just more logically and clearly like this one, right? So that's why I switched over to here. So that explains that one. We were not bounce checking correctly. So, back to what we were doing. Now, what we were doing was getting the desk set up. And what we're doing with the desk setup is getting the... Actually, I guess this is easier than I thought it was going to be, isn't it? Yeah, I guess so. What we could do... so right now we don't have any Z indexes. So that may be the change that we probably want to implement, is adding a Z index just to be on the safe side. Technically speaking, I could add this right now. I could add, let me just add it just so that I don't have to be vague about this. So define load desk text, return, actually frames. We only have one set of frames, don't we? Stream.gif is what I have. So that's a GIF. That's not even a... Okay, you know what? This is another utility we can add. Just in case... Well, nah, I don't want to. And I don't want to because, again, the GIF does not have transparency on it. I was going to say we could do a GIF splitter. Add split GIF into the utilities, but GIFs don't have transparency, right? So that would not be good for this situation. So let me hop back over to Piskel and let me make sure to minimize so I started the only thing you missed here was me starting to load desk text here, and then I hopped over here to stream.gif and saw that it was a GIF. Those are the only things you missed seeing. So point being is self.zindex equals 0 for right now. I'm just so that I can get this file saved really quick, but we're not going to handle that just yet, so that I can show you what is going on here. And let me hop over to Piskel not Piskel. I want to go to the Pixel Desk program that we wrote this morning. And let me open this in code. I'm kind of curious whether or not... No, okay, the streaming software does not kick you over to this version of it. Cool. And now I want to change this. Let me go ahead and swap you over just so you can watch me work here. There we go. All right, cool. So just so you have something to look at. So this is the code we wrote this morning, which outputted a GIF. I don't actually want to output a GIF right now. I want to take each of these frames and output them as a so as a single PNG. So PNG width equals, and we're just going to do a single row all the way across. That's how I'm going to format this. Equals we want base.width times however many our output is. Yep, length output. And that should be correct. Yep. So now we can image new RGB. I mean, technically, it's going to have to be RGBA. It doesn't have to be RGBA. But that is going to have to be RGBA now because we are no longer handling a GIF, and we had to change that from RGBA to RGB in order to handle the GIF. So that is why that was like that. Down here, I'm going to really quick for image in output. Actually, that will not work, I don't think, because I believe that it returns a new image. So I will just to do fix output if changing back to GIF to non-transparent if changing to GIF. Okay, cool. All right, and this new RGBA is size width by height, so PNG width, and height is where do we define that? My monitor.height? No, we can just use base.height. That would make most sense. And the color obviously is going to be, I mean, not obviously, it could be anything so long as we have a transparent background. And then that is going to be output equals, or output PNG for image in output I for I image in enumerate. Actually, no. Yeah. So there's a number of ways to do this. In theory, all of these output images are supposed to be the same exact size. Otherwise, we could keep track of our X index I think I'll do that just to be on the safe side. So x equals 0, x off, and then output png dot paste x off, or rather image x off 0, and then actually, can't this be a 2-tuple? Yeah, it can be a 2-tuple. All right, cool. And this is going to be image for that, and then we can x off plus equals image dot width. And then at the end here, output dot save test dot png, and we should hopefully be good. So I'm going to really quick run that script. I'm not going to add the PowerShell window on this one just because that is tedious for a 2-second thing. .end scripts activate Python init .py, or actually we got a CD. I got a CD at any rate. Come on. PowerShell just froze up for whatever reason. Now Python init.py. This is one of these things. Okay, I made a mistake. This is not output. This is output png.save. One of these things where I keep on writing or creating cll.py and cli.py, and I never actually end up using it. Kind of funny, but all right, and we just take a look at this really quick. And I guess that's correct, except for let us change this back to what it was before. That way we're going right to left, because right to left makes more sense than, or not really makes more sense. I should say it generate offset image x delta y delta x y y. Oh, x is shoot. Now I gotta redefine this. X is, the x needs to be, we decided, no, yeah, that's right, width. And then the x delta is 1 and the y delta is 0. That should be correct. There we go. It ran correctly this time. Let's take a quick look. Test.png. Looks like it's working correctly. Although it is going left to right, we could go right to left. That way you could actually read it. So x should be base.width plus what is that called again? Stream sample dot width, and this will be a -1. So let's run it that way. X minus 1 is correct, right? Base width. So, oh no, we don't have to add the stream sample. Man, you do this first thing in the morning and you don't remember anything, huh? All right, zoom out, and then come to the beginning here. And all right, yeah, so now the S is coming in on the right hand side of the screen and going towards the left. That is correct. Okay, cool. Awesome. That was 10 minutes that I didn't want to spend, but whatever. Let us get you switched back to the other window now. Pixel desk screen. Which window are you? Sample. There we go. And I can close this, and I can come back up here to Pixel Desk. Pixel Desk, test, rename this as stream.png. Somehow Japanese hopped on, stream.png. Cut that and paste that over into our folder, and you will see that pop up in just a moment. Paste. And let me delete stream.gif. And there is stream.png. Cool. Alright, back to here. Alright. We did not load the whatchamacallit yet. So return utils.split sprite sheet, utils.load, import rather sprite sheet. Sample dir, that is sound mixer, that is not sample dir. And this is stream.png. .resolve, just resolve for posterity's sake, and we are splitting it. Row height is sprite size again, and column width is 9. So each screen is 9 pixels. So that's 18 plus 3 is 21. Okay, and that is going to return a list, so we should be good there. And let me just get rid of that random import that it gave me that I did not ask for. Now, what we can do is this can be its own GIF, and it can overlap the desk, and it's not going to be a problem so long as we overlap the desk after we draw the desk. So that's what I was being vague about earlier, is technically it works, but we should probably implement rather Z indexes. So I'm going to do this just so that we can prove it works, and then we will implement Z indexes and do it correctly. So monitor text equals sprite dot stationary sprite representations equals load desk text. I'm not going to sneeze again. 1 second. Alright, I caught myself that time. Nice. Alright. And then we can add canvas.add sprite monitor text. And this is a little bit of a tricky part, and this is something else that we probably want to implement at some point. I'm just not sure how I want to go about implementing it, but let me go ahead and get an offset from the whatchamacallit, and we'll go from there, and we'll just hard code it for now. 1 2 3 4 1 2 3 4 5. Actually, Piscal tells me what the offset is. 1212. Okay, so 250 plus 12 and 250 plus 12. Easy. And now we can go ahead and canvas.move sprite monitor text offset equals 0 0. Okie dokies, artichokes, and let's run this and see what happens. No errors. Excellent. I'm going to minimize this time so that you don't have to cry. And there you can see the text moving across the screen. So yep, that did work exactly as I expected it to, which is excellent. So the problem again is that, let me do this and I will demonstrate. We're going to cut this and then paste it afterwards. So let's run the sample again and hop up to map.gif. And as you can see, there is no text. There is no text because the text is getting drawn behind the desk. And that is why we need Z indices. Z indices rather. So I'm going to leave this like this. I'm going to leave the desk after the monitor. And we're going to come in here and implement Z indices. So sprite z index. The sprite z index, that actually does feel like, so location and representation, you know what, because we don't take location as an attribute, we almost shouldn't include z index either. Almost. Nah, we shouldn't. We should not. So in that case, we are going to come over to canvas in that case, and on the add sprite, we're going to have z index int equals 0. And then down here, we're going to have sprite.z_index equals z_index. We could do type checking on the z-index, but I will not bother with that just yet. So where is our draw functions again? Oh, that's going to be underneath GIF. So in the render, I'm trying to think. Yeah, I mean, this, okay, so this is why we did it like this. Because in theory, we should also have an engine. We don't have an engine. The GIF itself is the engine. And therefore, the GIF is just going to handle everything at the same time. Okay, that's why I did not have render as part of the canvas. Maybe that is wrong. Maybe I should have render as part of the canvas. That makes more sense. But for the time being, I'm going to stick with my intuition from the other stream and just do it like this. So we're going to come in here and we're going to sort sprites. Key equals lambda sprite dot z index. Sorted in Python. And I did get key right. Yep. Okay, cool. So that should be everything that's required for us to fix it. Let us find out. No errors is excellent to see. So we're going to hop up here to map.gif. And I do not see it. So oh, I take it back. We missed one other thing that I needed to do here. Z-index equals 1000. This can be any number above desk. So long as desk is lower than monitor text, desk defaults to 0, so any number over 0, this will work. So let's bring that up, run it again, and hop up here to map.gif, and there we go. Alrighty, so we have successfully implemented that. The next thing that I kind of want to implement, and it's really a question of how I want to implement it, which is not something I've given much thought to, is so as you can see, for this guy, we came in up high and we put the locator, maybe instead of canvas.add sprite, the desk should have an add sprite or add something. I don't know what to call it. Add what's a good word for it? Shoot. I swear it's on the tip of my tongue, which is why I'm not stopping. Normally I would just say add whatever. I just stop talking and move on here. But I swear it is on the tip of my tongue. Shoot, video games. What do you call those? Cosmetic. Add cosmetic. That's the word I was looking for. Sorry, I just noticed that it says YouTube is not receiving enough video. That is fascinating. Let me hop over to my stream thing. Oh, we dropped 720 frames. That is the first time I've ever seen us drop frames. Fascinating, fascinating, fascinating. I wonder what's causing that. Huh. That is very interesting. I am surprised we're dropping frames. I'm just refreshing YouTube really quick to see what happens. Huh, okay, that thing went away, so I guess it was just a hiccup in my internet. Very interesting. I've never seen that before. At least not while streaming, at any rate. Obviously, internet slows down occasionally, but very rare for it to slow down while streaming, as far as my experience goes, at any rate. Alright, well, new record achieved, 720 frames dropped. If I'm running at 60 frames per second, let's check that really quick. 720 divided by 60. 12 seconds of video. Wow. 12 seconds of video dropped. That is a lot. Okay. I guess something happened. I guess somebody had a telephone pole somewhere. Somebody accidentally spilled their coffee on the cables at the internet company. I don't know. Something happened. Anyway, so we could have an add cosmetic deal here. Cosmetic could be its own sprite subclass. Yeah. You know what? Let's go with that. Let's make a new cosmetic sprite. Should it be a subclass? So the problem with making too many subclasses is when you gotta inherit, is that you have to inherit rather multiple of them, which is why. Let us see. Very interesting. I think we just dropped some more frames. Not to distract you or anything while I'm trying to think, but how do we want to go about this? Because, again, the reason this is coming up is because of this printer. So with this printer, the object that we add in here could be part of this printer. So right now we just have it automatically built in to the sprite. But technically speaking, we could change this to whatever. We could also do the same thing with the spool. We could change the spool color and animate different color spools. That's an option. So that is why we're working on that right now, solving this problem. I'm just trying to think if so we want to basically use this stationary sprite function right here. Not function class. It's going to want to be a stationary sprite. I don't think it will ever want to be a sprite 2D because it should never actually move on its own. And since it should never actually move on its own, we actually probably are fine subclassing the stationary class cosmetic sprite, stationary sprite, and then define init, etc. And parent is what we're going to want. Parent equals none. Parent equals parent. Self dot. Define at property. Define location. So this is where we're going to want to, and actually offset, do our magic. So it's one of those things. We're going to define the parent, define the offset, and then the only thing we got to worry about is when the canvas, the renderer, whatever is rendering it, wants the sprite's location, it needs to tell it a dynamic location instead of a static one. For all our other sprites, they have a static location, self.location, and that gets set by the by whatever, basically. And by whatever, I say by whatever, but let me find the canvas. So canvas move sprite.location equals target location, right? So this sets sprite.location, but we want to ignore that for our sprite. So that's why we're doing this. So where did I go? Pivoting sprite, 2D sprite, there we go. Self.location. So self.location will return self.parent.location xy equals parent.location, and then return x plus self.offset 0, y plus self.offset 1, and get that in there. Self.offset equals offset. There we go. And then at location.setter, define location self value return. We don't actually want to do anything. We want to just ignore whatever it's trying to do. So that should hopefully work. I think that's all we got to do. So let's test out this theory. One other thing. Actually, no. We will leave the z-index alone. And the reason we're leaving the z-index alone is because this cosmetic could, in theory, also be like, for example, auras, let's say. And the aura will want to have a negative z-index. So we will go ahead and allow the canvas to set the z-index for our for the time being. It's one of those things, in theory, the cosmetic determines its own z-index, but yeah, no, that actually does make sense. I just made my own argument for me. Excellent. The canvas determines its own, the sprite determines its own z-index where it's supposed to display. So, I'm going to just call this 0, 0 because it's going to ignore this. The add sprite function is going to call sprite.location and it's just going to ignore it. So I'm going to ignore it myself. And then I'm going to come over here to sprite z-index equals 0. I'll call it negative, or I'll call it 1. I'll default it as 1. Self dot z-index equals z-index, and then we can go ahead and come down here at property, define z-index, self return self dot z-index, and at z-index dot setter, define z-index self value return. Again, just ignoring any attempt to set the z-index. A programmer would be able to change the z-index on the fly if that's what they desire, which may be what you want. They can just come in here and modify this property right here. It's not protected or anything, so no big deal. But the canvas will not be able to accidentally set the z-index. So that is that. And we don't have to, because now this is going to be a monitor text is going to be a cosmetic sprite, and we set the default to 1. We now don't have to come in and set the default because we know desk is 0. So actually, you know what? I'm going to do one better. I'm going to set z-index to -1 for the desk. That way, my sprite, if my sprite wanders over there, he is in front of the desk. He doesn't end up behind the desk. The desk should be somewhat in the background. So that is that. And actually, my sprite should always be in the foreground. If I don't change this, then my sprite is going to end up in the is going to end up behind the text on the screen. So let's set my sprite to 500 z-index. There we go. Anything else we need to do? All right. So there is one more thing that we may want to do. We probably want to do. But I will go ahead and run this first, and then I will come back to it. And that has to do with this right here. These move sprites. So let us go ahead and hit that again. Self.parent.location. Let us come in here. Canvas. Let me pull that back up. I didn't minimize it for you, and that's okay because I didn't do anything. Create frame render if sprite.location equals continue. XY equals. So it's trying to render the text right now is what it looks like. I'm assuming this is the text because it's calling self.parents.location. And since it is doing that, that means that it has already rendered the table, the desk. The desk should have a location, so it shouldn't be... Oh, I know exactly what I screwed up here. I went too quick. Parent. Self.parent. I did not update this cosmetic sprite. Cosmetic sprite needs a parent equals desk. There we go. Derp, derp, derp. Going too quick. Oh, and yeah. So you'll notice that I have a whole bunch of attributes in here that I did not fill in. Offset equals 1212. There we go. Get on it. Get on it. There we go. Offset parent derp derp derp. We made a change. We did not update our change. Let's close that guy, get that guy out of my face, and go over to map. And if we zoom in, we can see stream is working as expected. Now, let me, just as a follow-up to what we were doing, change our location to 250, 250. Just so we can watch ourselves walk in front of the text. Run just fine. Open up map.gif. And it's one of those things, obviously, we don't have any paths right here. So it looks like we just walked right over top of the desk, like we're flying. So that's just one of those deals with something that we may want to add later on. It's just that I'm randomly populating and animating stuff right now, so it's not something I'm going to bother with. However, with these guys right here, so our stationary GIFs, we are calling move on manually. We may not want to actually do that. We might want to call canvas.animate idle sprites. Idle animations is probably what we want to do. And that would solve this whole entire problem of canvas.move sprite, where I got a set offset of 0, 0. I don't think it was a mistake to add that in and not solve it this way. I think having that in there still is a good idea because that makes sure that our sprites never move. What we put in there with the right here. So self.move and etc. Actually, no, that's right, because we're that would change animation. All right, never mind. I take it back. Ignore what I was just saying there. But point being is canvas. Now, canvas base. Should it be in the canvas base? And idle animations is the other question. I guess we call it... no, it's because... So here's the scenario I'm thinking of. I'm thinking of something like, for example, Fire Emblem, right? Where Fire Emblem, in theory, when a guy's moving, it has one set of animations. When it's stationary, it has another set of animations. So we may want to... Okay, you know what? There may be a difference between my desk and the Prusa printer. The Prusa printer may be an idle animation, and my desk may be an idle animation, and the Prusa printer may be an actual movement. That would probably be the best. In which case, we have two different classes here. Two different situations here. So, self.idle animations get triggered with no movement, and I think any sprite can have that. I think that's reasonable. Now, it's one of those things, more complex systems may have a variety of idle animations. For the time being, we're going to just assume that a sprite does the same thing over and over again. So we're not going to handle that situation right now. We do, however, need self.idle index equals 0, because we need to keep an index of what frame we're on of the idle animation rather. We're also going to, in canvas or move, probably in move. So in move, we're going to want to self.idle animation or idle index equals 0. So move is always going to reset idle index. Where is it? Move. No, that's fine. The question is actually... Oh no, that's part of stationary sprite. Okay, yeah, that's part of stationary sprite, so it should also follow the same rules. And then... this actually... So, the cosmetic may actually be a subclass of sprite instead at this point, because its move animations actually are more idle animations instead. So we will handle that one. So let's go ahead and change this. So stationary, was there anything else I'm missing here? Yeah, because so all these things, all these functions right here would be yeah. So a cosmetic sprite, we can change this to self.idle animation. Yeah, okay. So these guys only matter for moving. I'm going to say at this point that a cosmetic sprite does not move, because it does not move independently of a object. It just always has an idle animation. And in that case, we will never actually have to copy these down and replace them, because these should never get called, because a canvas or an engine should never call sprite.move on a cosmetic sprite. We also don't have to write sprite.move because it's a cosmetic sprite. So we just need to handle get image in here. We got to write a new get image rather, which is just self.idle animation. So let's go ahead and do that. Define get image self, and this is going to return self.idle animations, self.idle index. So there's that. And we should go ahead and implement a define cycle idle self, and this is always going to increment by 1 in theory. So self.idle index equal plus equals 1, and self dot idle index. I got an indle in here. If self dot idle index is greater than length self dot idle animations -1 self dot idle animation idle index equals 0. There we go. So same exact code you're used to seeing here, and that should be good, I'm thinking, for here, for this location. Now, one thing I do want to mention, these two lines of code could be rewritten to self dot idle index equals self dot idle equals max self dot idle index max min 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 max, no max. Anyway, point being is that you can do a min max here. I don't know why I'm blanking on how it works. Basically, the minimum of self dot, no, that just caps it. Never mind. I think I'm just going crazy. Yep, I'm just going crazy. Because you're not resetting it back to the back. So that would have been a capping function is what I'm thinking of. So ignore my blathering. So let us come back to canvas and frame. Is frame part of GIF? Frame is part of GIF. So self.active sprites, and again, this would be a situation that would be handled by the engine actually, rather than the canvas. But that's not what we're working with right now, so we're not going to worry about it. And this is also one of those things, back to the move proxies, that would make my life easier. Basically what I'm trying to do is check the check which sprites have moved yet before, and then trigger the other ones. So I want to keep a list of sprites that have moved. Frame. Self.frame. Create frames. Let me look at this really quick. We are in sample, right? Yeah. With canvas.frame. Let me see how canvas.frame is. Okay. Frame self. Okay. This is how I'm going to refactor this code as F. As frame, not as F. Frame dot move sprite. Is this how I want to do it? It might be how I want to do it. I don't know. I might be making a mistake here, but I'm gonna run with it. Define move self args keywords move sprite self.canvas.move sprite args kdubs and self.active sprites.append sprite. Do. Canvas base. Let me just look at this really quick. Move sprite. All right, sprite is the first whatchamacallit, so I can adjust. There's a safer way of doing this involving inspect and signature, but I'm going to go ahead for right now and just assume that sprite will always be the first argument because it is move sprite function, and that makes sense. So sprite, and now we have active sprites. So define animate idle sprites self, and self.canvas.animate idle sprites, and we will pass it how do we want to pass it? I think we want to pass it the inverse, so as opposed to the active sprites. So in that case, ignore me for just a second as I pretend like I know what I'm doing. Python does have the filter function, right? Okay, good. Python does have the filter function. Cool. Although I do like list comprehensions. Forget it. We'll use filter. I won't do it. No, I do want to do a list comprehension. I take it back. All right. Self dot sprite for sprite in self.canvas dot sprites if sprite not in self dot active sprites. Add sprite, self.sprites to depend. Okay, cool. That is idle, cycle idle, so that be correct. So now we just got to do this animate idle sprites. And this, I think, goes on to the base canvas. I think that makes sense. And I don't see a reason why there needs to be a listener right now. So, for idle animations. So, I will not bother with all this stuff where we listen for a, we project what we're going to do. We're going to say to something, oh, this sprite's about to function a idle animation. Do you want it to do that? No. Okay. I don't know that we necessarily need that callback right now, so I'm not going to bother writing a whole entire callback list like this. So for sprite in idle sprites, sprite.cycle cycle idle. This should be like that just because that's the way we're coding it right now. I did not put an underscore between idle and sprites just because I'm kind of considering that a type of sprite. So that's more of a name to me. So that's why I did not throw an underscore right here. Sprite.cycle idle. That should be enough, honestly. Because we're going to come back through and we're going to animate them anyway. So let us see. The next thing we got to do is we got to convert some stuff, right? So the stationary sprite, it's not going to be a stationary sprite anymore. It's cosmetic sprite, representation list, representation. So it does not, at this point, actually, representation, we can have rotation equals none. Actually, no, I take it back. We should have idle animations is what we should have. If idle animations equals is none, idle animations equals list. List idle animations. There we go. So that handles that one. That handles our cosmetics more specifically. So this is going to go to idle animations. And that is going to go to idle animations, and that's going to go to sprite. And we should be good at that point for the desk. Okay, so we're going to come down here to desk, and we're going to put the printer back in. Frame.move sprite. Printer 0, 0. Again, the printer, as I kind of said when we started this adventure right here, this sub-adventure, the printer kind of does have its own movement as opposed to the text on the screen, which does not have its own movement. It's more of an idle animation. So that is the reason. Bum, 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 bum. Cosmetic sprite, and this is now going to be idle animations. And this is now going to do that, and we should at the end of this. So actually, here's a good question. When we exit the frame, on this exit, perhaps we should call define, or not define, maybe we should call animate idle sprites. That honestly would make sense, because we almost always, again, want to animate the idle sprites. I don't see why we wouldn't. So let us go ahead and do that on the exit. Self.animate idle sprites. So before it exits, it's going to run through all the sprites that have not moved and animate them. And I think we're good at this point. Hopefully, let's see if it blows up. It blew up. None type pattern has no move sprite. Me random frame. So sorry, let me minimize that for you guys. Keep it an eye on you. I got you. So that was supposed to self.frame was supposed to return a frame. So let's go look at that. Define self frame, returns frame, frame initiates, and obviously is a frame with canvas.frame as frame. Define frame self returning. Why are you purple? Huh. I believe I did something silly there. Okay, that did not fix our problem though. Even though I'm pretty sure I did something silly, that did not fix our problem. So frame is still none for some reason. Frame self return frame self. Bum, bum, bum. Sample print frame. None. Okay, good. Print canvas.frame. Canvas.frame bound method. GIF single page canvas. Control Z. GIF, single page canvas, canvas and single page. It takes from canvas, so it accepts that. Single page canvas, let's see, that does not overwrite anything. Good. So, what is our dealio? GIF, canvas, canvas base, frame. Define self, frame, return frame self. All right, good. Excellent. All right. That is where I made my mistake. Okay. Yeah. Let me explain that one, because that one actually requires some explaining. The as here is for the with context. So the with context returns whatever. In there I had pass. Pass is equivalent to return none, basically, because there is no return function there. That when it exits the function declaration, it says, okay, there's no return here, so we're returning none, basically, effectively. So this canvas.frame technically right at this point equals frame, okay? Frame class instance. However, this with this as corresponds to the result of with frame instance. Sorry, I was so caught up in everything I was saying that I did that. So with canvas frame, okay, canvas frame initializes to a frame. The with context then simplifies this. So this goes from, this breaks down to, the interpreter breaks it down from with canvas.frame as frame, and then with frame, this is an instance right here, as frame, and then it does this with, so with frame instance dot enter as frame, that returns obviously none as frame, because that enter originally back over here was just a pass, so it was just returning none. So this enter function here, which it called right here, was returning none, and it was none as frame. So that's what happened there. That's the explanation. Oh boy. Okay. So let us check out the other error that we just got and see what happened. Printer 00. Non-type object is not iterable. Okay, sprite.location is not set, except for the printer. The printer was working before, wasn't it? So why now? Let's control Z a whole bunch here and see what happens. I explicitly called offset. Is that what's going on here? I'm pretty sure that's what's going on here. And it was. All right, clear. So, yeah, basically what was happening, it was taking that first thing, which is a tuple, right? And this may be something that we might want to fix. But in canvas, GIF, canvas, move. Where is move? Move sprite. Oh, that is in canvas. That's actually over here. So in here, obviously direction and then offset are two separate attributes. It took the first one as direction, and then it just said, oh, wait a second. It worked on that to determine, it attempted to determine offset. So what we probably should do And the funny thing is that I kind of feel like there is a newer signature thing that we can do, a signature trick, a way to define the parameters that, you know what, maybe I'm not thinking of it correctly. Anyway, my point being is we can come, let's say, here. If direction and offset, before here, let's say, if is instance direction tuple offset equals, ignore me trying to type JavaScript here. Offset equals direction equals none. Elif is instance offset actually, you know what, we probably don't have to. No, we should. Elif offset is, well, we shouldn't do this. I'm going to say we're not going to do that. We're not going to add the opposite direction. We're not going to. So right here, obviously, if the direction is a tuple, then we know that was actually supposed to be an offset. So we know that's just wrong. Now, technically speaking, people can yell at me and say that I shouldn't be doing this. That's not expected behavior to convert the parameters. It's frankly a very useful ease of use, life, whatever you're going to call that, life improvement, quality of life improvement. There we go. It's a very useful quality of life improvement and a very easy mistake for somebody to make. And I think it's easier to just catch it because it's really not doing any harm. Direction should never, ever, ever be a tuple to begin with. That doesn't make any sense at all because a direction is not a tuple. A tuple is an offset. So, for that reason, I feel perfectly okay converting it here. Again, the argument should be, no, that's bad, but I disagree. So, let us just come in here. So the stream, as you can see, is animating. And it looks like the printer is also animating. I'm trying to zoom in on the printer. And our animation is over already. Let's Control F5. Again, is there no reload GIF? I guess there's no reload GIF. All right. We'll just open it up. Yeah. All right. So our printer is definitely working here. Our stream is working. So that means that we have successfully animated idle animations, implemented idle animations rather. So that is, I think, everything I wanted to get done, because the only other thing to do here is to replace this little widget on our printer with a cosmetic. That is going to cause some issues in theory. It doesn't necessarily. It kind of does. It kind of does. So actually that does cause some issues. I'm going to have to think about how I'm going to want to handle those, because it's not terribly straightforward and it may require another class. I'm not entirely sure. Well, nothing requires another class. Let's be honest. Nothing actually requires implementing more classes. But it may be useful to implement another class. So my issue here is that the cosmetics right now, the way we have it set up as idle animations, whereas these cosmetics, quote unquote cosmetics here, that I would implement for this guy, the spool and the the figure, whatever we're printing on the printer, those two animations are actually based on the animation index of its parent. So that's actually a bit different. That's actually tied directly to the animation index, as opposed to this right here, which is simply an idle animation. So that will have to be handled separately. I'll have to think about how I want to do that one, and that wasn't something I was expecting to tackle on the stream, because it doesn't make any sense to tackle it until I've designed some more stuff for it, until we've done another pixel art stream. So for that reason, I was not planning on covering it, and we will not be covering it. But otherwise, we are well on our way here. The next couple of things to add to our animation software here is, well, at least the animation setup script that we've got running at any rate. I'm not going to call it animation software just yet, because again, we don't have an actual engine, so it's not really a thing. But point being is that we may want to put in paths, okay, that the character can only move around, and back to this situation here where we want to tie the animation of one sprite to the animation of another. So those are two features that we will want to add in the future. Again, the point of adding the paths is for doodads, background image sprites like this guy. It's so that we don't accidentally run over top of them. You can imagine how that would look in, Pokemon. If you had a house, pretend this is a house in Pokemon, right? And your character just started walking through it. That doesn't make sense. That's why Pokemon has paths in areas with sprites that you can't walk over. So, anyway, that's something we're going to want to implement in this next time. So, look forward to that stream. Before I sign off here, I do want to apologize for missing that second stream today. I mentioned it was a bit foobarred. Basically, and I don't recall if I mentioned it at this point in the stream, I have learned that I should give myself more of a mental break between streams. So I was going home for that. I set it up for 10 a.m. and then 1 a.m. And I sat there when I set it up and I said, okay, 3 hours. 3 hours is fine. Well, the first stream took from 10 a.m. to 11:30, 11:45, something like that, maybe close to 12. I can't remember exactly at this point. So it was nearly a 2-hour stream. I do remember that. It was nearly a 2-hour stream. And then that led immediately into me making lunch, scarfing lunch down, and then getting started on the stream. Working on the stream, getting prepped for the stream, and then starting the stream. So I basically had no mental downtime between the two streams to recover and switch gears. And that's something I'm just going to have to take into account in the future. I shouldn't be scheduling two disparate streams so close to each other. I think there's a possibility that, for example, had I scheduled this stream where we animate this stuff after the desktop scripting rather that we did this morning, these two streams that I did today, scripting streams that I did today, are close enough in type that maybe it wouldn't have been as bad. But at the very least, jumping directly from Python scripting to Fusion very well may have contributed to me being impatient and the stream not being very high quality. So, again, I just wanted to apologize. I wanted to have 3 streams today. We did not. We had 2 streams. That hopefully will not be the case going forward on days that I can stream this many times. I will make sure that I put enough time to recover between streams, and that does not happen again. So thank you for your patience, and as always, I hope you have a great and wonderful day, afternoon, or evening wherever you're at in the world, and I will catch you next time.